My dear students, I hope all of you are very fine. And after the previous class, now we are going to discuss about the second intro part of the number system of class 9 NCERT mathematics. Let's start. So now, today we are going to know between any two rational numbers how many numbers are there, how many rational numbers are there. Student, between any two rational numbers, there are infinite many numbers. If you want to say that 1 and 3, you say that only 2 is there, only single number is there. But it's not exactly. If I say it clearly, if we take any two consecutive numbers, then it will be very easy to you. Are there any numbers between 1 and 2? We say that no. Because there is a whole number 1 and 2 between, there is no whole number. It is absolutely right. There is no whole number between whole natural numbers between 1 and 2. But there are infinitely many rational numbers are there. How is it possible? We know that 1.1 is greater than 1 but less than 2. 1.2, 1.3, 1.4, 1.5 and so on. All are the less than 2 but greater than 1. There are so many numbers which are 1 point something but less than 2. They are 1 point something and they're greater than 1 but less than 2. There are infinite many numbers we can find between them. After that, you will say, is 1.1 a rational number? Yes, of course. Because it can be also expressed as P by Q form. You see, 1.1 is nothing but 11 by 10 because point is there. After this is before one digit before from the last, so that's why 10 will be there. We actually know it in the previous classes. So 11 by 10, similarly 12 by 10, 13 by 10, these all are the numbers. But 12 by 10, it is not in the lowest form, we have to make it in lowest form. So it will be 2 6s are and 2 5s are, it is nothing but the 6 by 5. When we will write, then we will write only the 6 by 5. So this is the number, these are the numbers which are lying between 1 and 2. There are so many infinite numbers lying between any two given rational numbers. So if there be any question, suppose you have to find any 6 rational numbers between 1 and 2. So exactly there 1.1, 1.2, 1.3, 1.4 you can say. If there be whole number, it is very easy to say. But in the other process, we can also solve it. Suppose there are two given number 1 and 2 and you have to find 5 numbers between them. Then you have to make 1 as its equivalent fraction as 1 upon 6 into 6. How is it possible? This 6 comes from there here, as I have to find out 5 numbers between 1 and 2. So I have to make 5 plus 1 equals to 6. So 1 by 6 into 6 equals to 6 by 6. And 2 will be similarly 2 by 6 into 6 is equals to 2 6 12 upon 6. We are making this to find out the numbers, required numbers very easily or in the exact form. So there will be no confusion. Numbers will be find out in a fixed manner. So that's why we are doing in such equivalent forms. So 6 by 6 and 12 by 6, they are nothing but equals to 1 and they are nothing, this is nothing but 1, 2. So between 6 by 6 and 12 by 6, how many numbers are there? As the denominator are same, so we can say that next one will be 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6 and 12 by 6. Sorry, 12 was there. So between 6 by 6 and 12 by 6, these numbers are there. These 5 numbers. There are so many infinite numbers, but there is only 6 numbers you have to find out. So I am showing this that we can find out on this form also. But here you listen that 7 by 6, it is both the P by Q form. There both P by Q values are the co-prime number. No factors are there, common factors are there, but the 8 by 6, so I have to reduce them. 2 4 just 6, 2 3 just 2 4 just 8 and 2 3 just 6. So 4 upon 3 will be written here. 3 3s are 9 and 3 2s are 6. So 3 by 2 will be there. And after that 2 5s are and 2 3s are. So 5 upon 3 will be there. So in the same system, 11 by 6 is there. No problem is there. There are co-primes, both of them. So numbers are required numbers are 7 by 9, 4 by 3, 3 by 2, 5 by 3 and 11 by 6. There are 1, 2, 3, 4, 5 numbers. We have to find out the 5 numbers. So that's all. So I think it is clear to us that how to find out the finite numbers or required numbers of rational numbers between any two given rational numbers. Students, after this we will solve the exercise problems. So I am cleaning this. Let's start for the exercise problem. Now, exercise 1.1. We are going to start to solve the problems. Exercise 1.1. The problems is there. First problem. One is saying that is 0 a rational number? Can you write in the form P by Q? Is 0 a rational number or not? Is 0 a rational number? And the second one is, can you write in the form of P by Q, where P and Q are integers and Q not equals to 0? First of all, we have to consider the definition of rational number. We have to consider the definition of rational number. What do you mean by the definition of rational numbers? We know that according to the definition, the numbers which can be expressed as P by Q, where PQ are integers and Q not equals to 0, are called rational numbers. Are called rational numbers according to the definition. Here, let's see, can we express 0 as P by Q form? Let's 0 equals to, we may write 0 by 1, we may write 0 by 2, we may write 0 by 3, anything 0 by except 0, 0 by non-zero terms if we write, then non-zero rational integers if we write, then it must be 0. So it is all these forms are in P by Q form. P and Q both are integers, but Q not equals to 0. So that's why it is satisfying the definition. So here 0 is this. So that means we can express 0 as P by Q form as in P by Q form, where P and Q are belongs to rational numbers and Q not equals to 0. So at the end of the conclusion we have to write that, so therefore 0 is a rational number. Therefore 0 is a rational number. So I think it's clear to you, question number 1. Now we are going to question number 3. Let's go for question number 3. So I am cleaning this. I hope this is understandable for you. So let's clean this. So we are doing the exercise problems. Exercise 1.1. I am writing here. Question number 2. Find 6 rational numbers between 3 and 4. Find 6 rational numbers. 6 rational numbers between 3 and 4. Student, be careful about this. The given numbers, I am going for the solution. We have to find out six rational numbers between 3 and 4. Listen carefully. 6, there are infinite many numbers are there. You have to find out only 6. And there may be any 6. There are infinite many rational numbers. We have to find out any 6 rational numbers. As the previous discussion, what we have discussed here, that if there be 2 rational numbers, then there are infinitely many rational numbers such as more than 3 and less than 4. How is it possible? 3.1, 3.2, 3.4, 3.5, 3.6, and 6 we have to take. So we are going to 1, 2, 3.1, 2, 3, 4, 5 and 6. So we have to find out 6 rational. These are the required numbers. Required numbers we can say. But if you want to express this in the form of P by Q, then we have to write 3.1 as point will be related here 31 by 10, 31 by 10, 32 by 10, 33 by 10, this one. But we have to make them in the simplest form, where we can do that 31 by 10, it will not be, they are co-prime. 32 by 10, if you want to reduce, then 2 16s are, 2 5s are, so 16 upon 5 will be there. 33 upon 10, 34, 2 17s are, 5s are, 17 upon 5, 5 7s are, 2s are, 7 upon 2, 18, 5, 2 18s are, 2 5s are. So these are the required 6 rational numbers between 3 and 4. So required numbers are these. But if you want to find out in different process, the second method what we have discussed before, then you also find out. I am also discussing the second method also. I am cleaning this. Now, according to the second method, we have to find out 6 rational numbers between 3 and 4. So, 6 plus 1 equals to 7. 3 equals to, we are going to 3 into 7 by 7. 3 into 7 by 7 is equals to 21 by 7. Now, 4 is equals to 4 into 7 by 7 equals to 28 by 7. So here we have find out 2 numbers. Between them, how many numbers are there? We have to find out. So the required numbers are, therefore the required numbers be 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7, this one. So there are 6, 1, 2, 3, 4, 5, 6. Now you can say that the previous method, the answers were different, but in this method, the answer is different. I have told before also, there are infinite many numbers. So you can choose any of them, any 6 of them, as 6 are the record. So that's why any 6 of them you can took out. So obviously they should be lying between the 3 and 4. If you want to exactly say that 3 and 4, that means 3 more than 3 point something. If you more than 3, that means 3 point something will be there, but less than 4 you have to keep in mind. Any numbers you can put. So both the methods I have discussed, you can choose any one of them as your suitability. So you can take it. So go for the next question. The number 3, find 5 rational numbers between 3 by 5 and 4 by 5. So find 5 rational numbers. Number 3 I am discussing about. Find how many rational numbers? 5 rational numbers. 5 rational numbers between 3 by 5 and 4 by 5. 3 by 5 and 4 by 5. Now we are not going for the first method. We will take out this second method, which will be easy for us. Clear this? There was 6. So 6. So 6 plus 1, 7 we have done. But here now 5. So we have to write down. We have to find out 5 rational numbers between 3 by 5 and 4 by 5. See here. So here will be, as 5 is there, so we will write down here 5 plus 1 as 6. 5 plus 1 as 6. Again, we will make here 3 upon 5. The given rational number was there. So we are making these rational numbers as in the equivalent fraction. 3 by 5 into, we have to multiply this 6 into by 6 equals to 18 upon 30. Again 4 by 5 is there, so we will multiply 4 by 5 by 6 upon 6, so it equals to 24 by 30. See here, both the denominators part are equal, so we can find out easily the required numbers. So therefore the required numbers be 18 and 24 lying between there. The numbers, 5 numbers we can easily find out. 19 upon 30, 20 upon 30, 21 upon 30, 22 upon 30, 23 upon 30, as 24 is the last one. So there are 5 rational numbers you can write. But here we have to make them the simplest form also. 19 upon 30 we can't reduce, but here 0 0 will be cancel out, so 2 3 will be there. Be sincere about it. We have to cancel out and make the simplest form, as P and Q are co-prime every time. So there 2 11s are 2 15s are. So 11 upon 15 we have a right. Again 23 upon 30, no reduction. So it's clear to you that how to find out the 5 rational numbers between 3 by 5 and 4 by 5. It's clear? I think it's clear. Students, now we are at question number 4. And the question number 4 is saying that state whether the statements are true or false. Give reasons for your answers. So, first of all, we have to check out the statements. First statement is saying that every natural number is a whole number. Every natural number is a whole number. First of all, if you want to check out natural numbers, you know that what are natural numbers. Natural numbers are nothing but 1, 2, 3, 4 and so on to the infinity. And at the same time, whole numbers are natural number including 0, along with 0. That means in the whole number and natural number there is a common part. You see that from here to here and here to here there is a common part, whole and natural numbers. All the natural numbers belong to whole number, but all whole number not belongs to natural numbers because there is an exceptional case 0. So that's why we can say that every natural number is a whole number. And that's why we can say that every natural number is a whole number. That means the statement is true. Why? Since every natural numbers belongs to whole numbers, series, therefore we can say that every natural number, the given statement is true. The given statement is true. So I think it is clear. With natural numbers and whole numbers, if there be natural numbers are the part of the whole numbers. So all natural numbers are the members of whole numbers. But all whole numbers are not the members of natural numbers. So natural numbers are in the bag of whole numbers. So every natural numbers are also the whole numbers. So every natural numbers is a whole number is the right or true statement. So or true statement. So clear, I think it is clear. So let's go for the another question. So I'm cleaning this. The another question, what is saying? Another question is saying number 2. Number 2 is saying that every integer is a whole number. Every integer is a whole number. The question is saying that every integer is a whole number. Every integer is a whole number. So first of all, integers, what do you mean by integer? Integers are nothing but a collection of negative numbers 0 and the natural numbers. Integers. First of all, I am saying the integers. Integers are, who are the integers? Integers are negative numbers and whole numbers. This is nothing but the collection. The collection of negative numbers and whole numbers. We know negative numbers -1, -2, -3 and so on. And whole numbers we know that starting from 0, 1, 2, 3. So from that these numbers are the whole numbers. Here the statement is saying that every integer is a whole number. See here, integer is the combination or the collection of negative numbers as well as whole numbers. The negative numbers plus whole number mix is integers. So that means all integers are not whole numbers. There may be negative numbers and whole numbers. Such as, if we take examples, if we take example -3, I am saying -3 is integers, but it is not whole numbers. -3 is an integer, but it is not whole number. So we can say that every integer is a whole number, because whole number is the part of integer. So every whole number is a integer, is an integer. But the opposite or the reverse is not true, because every integer is a whole number, because integer, the part of integer is a whole number. So I think it's clear to you. So given statement is absolutely false. So we have to say, we conclude that every integer is a whole number is a false statement. Student, now we have come at the third statement. The statement is saying that every rational number is a whole number. Every rational number is a whole number. Is it right or wrong? First of all, we know that the rational number definition. According to this definition of the rational number, according to definition of rational number, we know that the number which can be expressed as P by Q, where P and Q, where PQ belongs to PQ or integer belongs to Z and Q not equals to 0 are called rational numbers. Are called rational numbers. Here that is definition says that the statement is that every rational number is a whole number. That means examples, if we want to give some examples, you may give 0, 1, 2, this type of numbers. You may give here -3, -4, -5, etc. This type of numbers. You can give 2 by 3, 4 by 5, like these numbers also. That means rational numbers may be in this, may be whole numbers, maybe negative integers, maybe the fractional form, but it is saying that every rational number is a whole number. But it's not exactly true, because every rational numbers are not whole number. The part of the rational numbers are whole number, but not all, because rational numbers are the collection of fractional form of the numbers. Here you see this, the integers also. So not only whole numbers. So this statement is absolutely false, because every rational number is not whole number, because there may be integers, negative integers also, there may be in the fractional form also. So that's why this is false. I think it is clear for this exercise 1.1 problems. So we are finishing the lectures now, and again we will start the new exercise for next video. Thank you. Stay safe and stay fine.